black holes are by far the most terrifying objects in space. Their sheer enormity and the mystery they hold send a shiver down the spine of scientists and curious minds alike. We can scarcely imagine the scale of these cosmic giants, objects so massive and so powerful that they warp the very fabric of space-time. Some black holes are so large that they exceed our wildest scientific predictions, defying all our understanding of how the universe works. These cosmic beasts can be several billion times the mass of our Sun, and the impact of their existence reaches far beyond their gravitational grasp. Yet, despite decades of research, these cosmic anomalies remain filled with secrets and unknowns, often leaving us with more questions than answers. But here's the thing, over time, black holes have gone from being theoretical concepts, merely equations in Einstein's theory of general relativity, to real, tangible objects we can observe and study. It wasn't so long ago that scientists debated whether these colossal voids were even real. They were first described mathematically in Einstein's equations, showing what happens when a star collapses in on itself. The idea was radical at the time, a singularity of infinite density that could trap everything, including light. But in the decades that followed, it became clear that these cosmic anomalies were not only real but also central to understanding the very structure of the universe. In fact, black holes are now seen as key objects for understanding the cosmos itself. It turns out that they do far more than just gobble up matter, they shape the very evolution of galaxies and even influence the formation of new stars. From the moment the first black hole was definitively confirmed in the 1960s, we've been on an exciting journey of discovery. One of the earliest confirmed black holes was Cygnus X1, a stellar mass black hole located about 6,000 light-years from Earth. It has a mass of about 15 times that of the Sun. That discovery was just the beginning of a much larger story about these strange objects. Over the years, black holes of all sizes, from stellar mass to supermassive, have been found, and they've shocked us by being even more fascinating and mysterious than we had ever imagined. What if I told you that black holes existed in the universe long before the first galaxies ever formed? That's right. New research has shown that some of the most massive black holes we observe today might have formed in the very early stages of the universe, possibly within the first few 100 million years after the Big Bang. This opens up a whole new chapter in our understanding of the cosmos, as it challenges everything we thought we knew about black holes, galaxy formation, and even the early universe. These ancient black holes may have been around from the very beginning, growing to incredible sizes much faster than we ever thought possible. Some of these black holes could be as large as 40 billion solar masses, far larger than anything we previously believed could exist. Just thinking about the size of a black hole that's 40 billion times the mass of our Sun is enough to make your head spin. Yet, this is precisely the reality of what we're uncovering. These discoveries have completely changed the way scientists approach the study of black holes. Previously, it was thought that these colossal black holes formed slowly over billions of years, growing by accreting matter from the surrounding space and from mergers with other black holes. However, recent findings have revealed that some of the most massive black holes in the universe might have formed much earlier than we thought and in ways that defy the traditional models of black hole growth. These discoveries suggest that black holes might not only be the product of dying stars but could have formed through entirely different processes in the early universe. In fact, one of the most shocking revelations in recent years came from the discovery of a black hole in the galaxy GNZ11, located about 13.4 billion light-years away. This galaxy is one of the oldest we've ever observed, and it was already home to a massive black hole, one that might weigh several billion times the mass of our Sun. How could a black hole so large have formed so soon after the Big Bang? Scientists are still trying to answer that question, and the implications are profound. The presence of such massive black holes at the dawn of the universe raises significant questions about their origin. Did these early black holes start out as massive objects right from the start? Or did they grow exponentially in ways that we don't yet fully understand? Some researchers think these black holes may have been born big, while others argue that they could have grown incredibly fast, perhaps even devouring matter at an unprecedented rate. It's still unclear how these black holes formed so early and grew so large, but the discovery challenges everything we know about the early universe. Interestingly, this discovery also highlights the importance of cutting-edge technology in advancing our understanding of space. The James Webb Space Telescope, JWST, launched in 2021, has opened up a new era of astronomical observations, allowing scientists to peer into the farthest reaches of space with unprecedented precision. The JWST's ability to detect faint light from some of the earliest galaxies and black holes has provided invaluable insights into how the universe evolved in its infancy. By observing galaxies like GNZ11, the JWST has helped confirm the existence of some of the most distant and ancient black holes ever discovered, pushing the limits of what we thought was possible. But the story of black holes doesn't end there. While the discovery of ultramassive black holes in the early universe is both exciting and perplexing, we must also consider the other types of black holes that exist in the cosmos. Not all black holes are supermassive or ultramassive. There are also stellar mass black holes, which are formed from the remnants of dying stars. These black holes typically have masses between 5 and 20 times that of the Sun and are often found in binary star systems, where they can pull material from a companion star. These black holes are much smaller than their supermassive counterparts but still have a gravitational pull strong enough to distort spacetime and cause phenomena like X-ray emissions. One of the most well-known examples of a stellar mass black hole is Cygnus X1, which was the first black hole to be definitively identified in 1964. Cygnus X1 was discovered through its X-ray emissions, which were the result of material being pulled from a companion star and falling into the black hole's accretion disk. Since then, countless other stellar mass black holes have been discovered, many of them in binary star systems or even in isolated locations within galaxies. These black holes, while not as massive as supermassive black holes, still play a crucial role in the evolution of galaxies and the dynamics of stars. They are also excellent laboratories for studying the properties of black holes and testing our understanding of general relativity. As we move from stellar mass black holes to their larger counterparts, supermassive black holes, the scale of the cosmic mystery becomes even more staggering. Supermassive black holes, like those found at the centers of galaxies, can range from millions to billions of times the mass of our Sun. These black holes are thought to have formed early in the history of the universe and to have grown over time by accreting matter from their surroundings. The black hole at the center of our Milky Way galaxy, Sagittarius A*, is a prime example of a supermassive black hole. It has a mass of around 4 million solar masses and plays a central role in the dynamics of our galaxy. But there are even larger supermassive black holes, like the one in the galaxy M87, which has a mass of 6.5 billion solar masses. These black holes are among the most powerful objects in the universe, and their influence extends far beyond the galaxies in which they reside. But even supermassive black holes don't hold the title for the most massive black holes in the universe. That honor goes to the ultramassive black holes, objects that can weigh as much as 40 billion solar masses or more. These black holes are truly gargantuan, and their size and gravitational pull make them incredibly dangerous. One example of an ultramassive black hole is located in the galaxy T618, about 10 billion light-years away. This black hole is believed to be at the center of a powerful quasar, a highly energetic region of space where matter is being rapidly consumed by the black hole's accretion disk. The quasar's immense luminosity outshines the rest of the galaxy, making it difficult for astronomers to observe the galaxy itself. Instead, they study the black hole by examining the light emitted from the accretion disk and the quasar. While ultramassive black holes like T618 are terrifying in their size and power, they also hold the key to understanding some of the most fundamental questions about the universe. For example, how did these black holes form? Did they start out as smaller black holes and gradually grow over time, or did they form from the collapse of massive clouds of gas and dust in the early universe? And what role do these black holes play in the formation of galaxies and the evolution of the cosmos? These questions are still the subject of intense research, and as our tools and techniques improve, we are likely to learn even more about the role of ultramassive black holes in shaping the universe. The mystery surrounding black holes doesn't end with their size. Even the smallest black holes, those as tiny as an atom, are still a topic of intense speculation and research. These so-called primordial black holes are believed to have formed in the very early universe, shortly after the Big Bang. They may have originated from tiny fluctuations in the density of matter and could have been distributed throughout the universe. Over time, these primordial black holes could have merged with one another to form larger black holes. It's even possible that some of them eventually encountered the remnants of dead stars, further contributing to their growth. The existence of primordial black holes is still a matter of theoretical speculation, but recent discoveries, such as the detection of gravitational waves from merging black holes, suggest that these tiny black holes could be more common than previously thought. This brings us to a fascinating question: could black holes be gateways to other dimensions or even other universes? For decades, scientists have speculated that black holes might not be simple cosmic dead ends but could instead act as tunnels or wormholes connecting different points in space-time. While this idea has captured the imagination of scientists and science fiction enthusiasts alike, it remains highly speculative. More recently, the idea of wormholes and black holes as dimensional gateways has largely been discounted. However, some researchers still believe that black holes might hold the key to understanding other dimensions or parallel universes. Whether or not this is true remains to be seen, but the notion of black holes as portals to other realms continues to be an intriguing idea. Another mind-bending idea comes from renowned physicist Roger Penrose, who in 2015 proposed a theory about a cyclical universe. According to this theory, black holes at the end of one universe could play a crucial role in the birth of a new one. The theory suggests that when black holes suck up most of the matter in the universe, they could eventually reach a point where they collapse, creating a standstill before the universe begins anew with a new Big Bang. In this framework, black holes might be seen as the midwives of new universes, carrying the information of the old one and giving birth to the next. While this idea is speculative, the recent discoveries made by the James Webb Space Telescope have reignited interest in Penrose's theory and other ideas about cyclical cosmology. In the end, black holes are more than just strange and terrifying objects. They are central to our understanding of the universe, from its earliest moments to its distant future. Every discovery we make about these enigmatic entities leads to more questions, pushing the boundaries of our knowledge and challenging the very laws of physics. The mysteries of black holes, both large and small, continue to captivate scientists and the public alike. As we look further into space and peer into the depths of these cosmic giants, we can only wonder, what will we discover next?